Welcome back. Now we are in chapter 6, rational expressions, and we will work on section 6.2, adding and subtracting rational expressions. First objective is adding or subtracting rational expressions with a common denominator. If P over Q and R over Q are rational expressions, then P over Q plus R over Q is going to be equal to P plus R over Q. That means if they have the same denominator, it's going to be easy. You just add the numerators and keep the denominator, right? And this is going to be the same thing for subtraction. Working out this example here, and you can realize that the denominators are the same, right? Check here. The denominators are the same. If they have the same denominator, what do? You just repeat the denominator, 2p plus 7, and add or subtract the numerators. In this case here, 4p minus 3 plus 3p plus 8. Combine like terms, we have 4p with 3p and negative 3 with 8. This is equal 4p plus 3p, 7p, and negative 3 with 8, positive 5, over 2p plus 7. And this is the result of this addition. Let's work another example, and again it's going to be the same procedure because the denominators are the same. So draw the line here, the bar, the fraction bar, repeat here the denominator, and you are going to add or subtract. In this situation here, subtract the numerators. And actually we can identify that this is a situation where you can simplify even further, because you can factor out 8 on the numerator, and this is going to result 8 times y minus 2, right, over y minus 2. And it's possible to simplify, because y minus 2 over y minus 2 equals 1. The result is 8. One more example, and always check, always be sure that the denominators are the same. If the denominators are the same, it's going to be kind of easy, because you just repeat here the denominator, y squared plus 3y minus 10, and on top you just add or subtract the numerators, 3y minus 6. Always try to simplify, and actually the solution needs to be the simpler rational expression that you can find. And the solution here, we can factor out 3 on the numerator, 3 times y minus 6, and let's think about the denominator. We need to find two numbers. Let's write here on top. The multiplied is equal to negative 10, and the sum is equal to 3. Thinking about it, I'm thinking about 5 and negative 2. Two numbers. 5 times negative 2, 10. 5 minus 2, 3. And we can rewrite this expression here of the denominator. You can rewrite factoring as y plus 5 times y minus 2, right? Actually, I made a mistake, sorry. Let's fix this. This is not 6. This is 2. Because now actually, after factoring out the denominator, you can simplify. See? You can simplify here. And then you have as the simpler rational expression 3 over y plus 5. This is going to be the solution. Always try to find the simplest rational expression as the solution of the problem. Next objective, number 2, identifying the least common denominator, LCD, of rational expressions. And to add or subtract rational expressions with unlike denominators, you have to change them to equivalent forms that have the same denominator, a common denominator. This involves finding the least common denominator of the two original rational expressions. So now we don't have, now we're gonna find, we will work to find the least common denominator, and later we will work with addition and subtraction of rational expressions with different denominators. Finding the least common denominator, first you factor each denominator completely, and the second step, the LCD is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any factor denominator. Let's see how it works. Let's see on an example how to work out the least common denominator. Find the least common denominator of the rational expression 6y. This is one of the denominators, 6y, and 4y plus 12 is another one. So let's work here. First step, remember the steps, factor out each denominator. So 6y is equal to 2 times 3 times y, right? And 4y plus 12, we can factor out 4, and 4 is actually 2 times 2. Let's factor out 2 times 2 multiplied by y plus, and here is going to be 3. This is the second denominator here. Now let's compare. Let me just change one thing here so we can compare. Then see 4y plus 12 equals, okay. This is the whole thing factored out. And on the bottom here, let's write the least common denominator. Each unique factor, then we have 2, and we have 2's on the bottom. The one that have more 2's is this on the bottom, so we're gonna use this, 2 squared, or 2 times 2. Another unique factor is 3. We don't have on the bottom, but we have on the top, so 3. And y, and also y plus 3. And that means that the least common denominator is equal to 2 times 2, 4, times 3, 12, times y plus 3. Another example, and I don't even looking at the numerators because we are interested in denominators, right? So one of the denominators is this, x squared plus 4x plus 3, and another one is that one here, x squared plus 10x plus 21. Let's write down here each one, x squared plus 4x plus 3, and we need to factor it out. And remember, to factor it out, we need to find two numbers. Find two numbers that multiplied is equal to 3 and the sum is equal to 4. And I can think about 1 and 4. The 1 and 3 and 1 and 3. Right? Multiplication 1 times 3, 3. 1 plus 3, 4. Good. That means you can rewrite this one here as x plus 1 times x plus 3. Let's check the next one. Now we have the denominator is x squared plus 10x plus 21. Same thing, let's write here on top. We need to find two numbers, two different numbers that multiplied is equal to 21 and sum equals to 10. Think, and I'm thinking here 7 and 3, because 7 times 3, 21, and 7 plus 3, 10. And I'm kind of doing this fast because I actually have been working with these numbers and I can think about this solution faster. But the way this usually goes is you try, you guess two numbers, try, then you adjust and try again, and maybe on the third attempt you're gonna find the couple of numbers that satisfy this condition. Okay, so x plus 7 multiplied by x plus 3. And finally, let's calculate. Let's find the least common denominator. The least common denominator is going to be all the unique factors. X plus 1 is a unique factor, so multiply, add here, write down here x plus 1. And another unique factor, x plus 3, we have here on both denominators, and both have exponent 1. So we just gonna need once x plus 3. And another unique factor, x plus 7. And this is the least common denominator for that example. One more example, and we have here 5x squared minus 5. Factoring it, we can see that we can factor out 5, right? 5 times x squared minus 1. And can we factor even more? Can we factor even more? Remember, there's a special product, a squared minus b squared equals a minus b times a plus b. Remember this? And we can apply here because 1 is the same thing as 1 squared. So we can also apply here. This is 5 times x minus 1 times x plus 1. So this is completely factored. The next one, x squared minus 2x plus 1. And the method here to factor this out is finding the numbers, finding the couple of numbers. The multiplied is equal to 1 and the sum is equal to -2. And I can think about these two numbers and kind of easy, -1 and -1, because if you multiply -1 and -1 is 1, and if you add -2, so that means x minus 1 squared. Finding now the least common denominator. Least common denominator. Unique factors. 5 is a unique factor. So write down here 5. X minus 1. Is x minus 1 a unique factor? Yes, we have it here, and we have it down on this denominator as well. Then we're going to use the one that have the greatest power. The greatest power is this second one, that is squared, right? And another unique factor, x plus 1 times x plus 1. This is the answer. This is the least common denominator for that pair here of denominators. And have a look at this. One is x minus 3, and the other one is 3 minus x. Can we find the common denominators here, or least common denominators? Actually, you can rewrite, let's say we rewrite this on the bottom, factoring out the negative, or minus 1, and this is going to be negative x minus 3. And check it out, this is the same, right? Actually, this is the same. And what you're gonna do here, you're gonna they have the same denominator actually, but this second one is a negative rational expression. You can rewrite as negative 2 over x minus 3. Okay, and then you're gonna see they will have the same denominator. Next objective, number 3, adding or subtracting rational expressions with unlike denominators, different denominators. And that's why we are working, we are learning how to find the least common denominator, because we're going to use it. Adding or subtracting rational expressions with unlike denominators, you will need to follow this step by step. Find the least common denominator. We'll write each rational expression as an equivalent rational expression whose denominator is the least common denominator that you found, and add or subtract the numerators, writing the results over the denominator. Simplify whenever it's possible. Let's try this one. We want to add these two rational expressions, 15 over 7a plus 8 over 6a. And first step, find the least common denominator. And we can actually factor the denominators out. This one is just 7 times a, right? This one. And this is 2 times 3 times a. So unique factors, we have 7, we have a, we have 2, and we have 3. That will result in 2 times 7, 14 times 3, 42. Is it right? Yes, I think so. 42a. Now we will change each one of the fractions to make them have the new denominator, the least common denominator that we found. So let's write down here. Here is going to be 42a, and this is going to be 42a. To make 7a, the original fraction, the original rational expression here have denominator 7a. To make it into 42 times a, we need to multiply by 6, both on the bottom and on the top, right? Then we make it equals to 42a. So we will multiply here on the top by 6. And the next one, to make 6a into 42a, we need to multiply 6a by 7. So we need to multiply on the top and on the bottom by 7. This is going to be 7 times 8. Now we can write everything here with just one denominator, 42a. 6 times 15, 90. 7 times 8 is 56. And the result here is going to be, let me move here, 146 over 42a. Remember, when you present a solution, you have to present the simplest rational expression, the simplest fraction that is possible. And we can actually simplify, divide both numerator and denominator by 2, and this is going to be 73 over 21a. And this is the simplest rational expression and will be the answer for this example. And we have here another one, another example, and this is kind of interesting because it's kind of similar. This last thing, let me show you here. This, remember this one? And let's apply the same thing here. Check, they actually have the same denominator, but with a negative sign. So let's rewrite here 5 over 2x minus 6 minus, and here we will rewrite as a negative, and 2x minus 6. Negative with negative, positive, 5 over 2x minus 6 plus 3 over 2x minus 6. And we can actually, it turned out to be two rational expressions with the same denominator. And 5 plus 3, 8 over 2x minus 6. Can we simplify a little bit more, even further? I think so, because you can divide both the numerator and the denominator by 2, right? You can divide. And this is going to be equal, or a divided by 2, 4. And 2x minus 6 divided by 2, x minus 3. And now we cannot simplify even further. This is the answer, which is the simplest rational expression that we can find. Another example, now we have, and the denominators here, x squared minus x minus 6. Let's factor this out. And remember, find a number that multiplied is equals to negative 6 and sum equals negative 1. Think, and maybe we can use the couple, the pair, negative 3 and 2, right? Because negative 3 multiplied by 2 is negative 6, and negative 3 plus 2 is negative 1. Rewriting x minus 3 times x plus 2. Next one, x squared plus 5x plus 6. Okay, again, now let's do in this side here. Two numbers, a couple of numbers that multiplied is equals to 6, and now the sum is equal to 5. And thinking, and I think we're gonna go with 3 and 2, right? Multiply 3 times 2, 6, and 3 plus 2, 5. So x plus 3 times x plus 2. Finding the least common denominator. Write down here the unique factors, and we have a unique factor here, x minus 3, and we have another unique factor. We have it here and on the bottom with the same exponent, right? Exponent 1. We just need to write once, x plus 2. And there's another unique factor here, x plus 3 times x plus 3. This is the least common denominator. Applying to that rational expression the addition of two different rational expressions, then we have here on the bottom this one. Let's write the equivalent. So is x minus 3 times x plus 2, right? And here on the top 4. And plus, let's write the equivalent here on the bottom, x plus 3, x plus 2. Nice. To complete this bottom here and make the least common denominator, we need to multiply by x plus 3, right? Then I have x plus 3, x minus 3, x plus 2. Okay. And on this one, we need to multiply by x minus 3. X plus 3, x plus 2, x minus 3. Don't forget to multiply on the bottom, on the denominator, and on the top, the numerator. Here the same, on the bottom and on the top. Let me see if I have more space here. No. And to complete my calculations, I need to make some space. Let me clear this up. Clearing more space here. And moving this a little bit up. Great. Completing the calculations. We can write now everything with the same denominator, right? X plus 3, x minus 3, and x plus 2. And on the top we add the numerators. 4. Let's make the distribution here. 4 times x for x plus 4 times 3, 12. Plus x times x, x squared, and x times negative 3, negative 3x. Combine like terms, 4x minus 3x plus x and plus 12 over x plus 3, x minus 3, x plus 2. And let's think if we can simplify even further. And I don't think so, because we cannot factor and find something that will simplify the denominator. This is going to be the answer, and you have to check out if you can simplify further. And actually, no, there's no way. I cannot see any way of simplifying it a little bit more. Moving on to the next example. And now we have, let's see the denominators, x minus 1, another denominator here, x squared minus 1, and another denominator x plus 1. We cannot factor it out more, this one, the first one, x minus 1, that's it. Maybe this one we can factor it out a little bit more, and the last one, that's it, we cannot factor it out. And the second, we will apply that property, a squared plus b squared equals the special product, right? A minus b times a plus b. Let's apply this special product here. X minus 1 times x plus 1. And here is just x plus 1, and there is just x minus 1. Calculating the least common denominator. Unique factors, x minus 1, we have it here and there, and the second denominator, we just write it once. And the x plus 1, we have here on the second denominator and on the third denominator, and we just write it once. This is our least common denominator. And yeah, we have some space, but let's make space here. We found the least common denominator, right? And let me clean this up. Now let's write each rational expression here, each one with the new least common denominator. Each one we're gonna use the same least common denominator. And let me rewrite 7 over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. To make this first one as the least common denominator, we need to multiply x plus 1, right? And we're going to multiply on the bottom and on the top as well. This is the same thing as the least common denominator, and the last one you have to multiply by x minus 1 and multiply on the bottom and on the top. Now it's great because we can rewrite the whole thing, and this line is not straight. Let me draw a straight line and try straighter. Yeah, that's right. The least common denominator, x plus 1, and the order doesn't matter here, x minus 1, okay. And let's add and subtract the numerators now. Working out the distribution, then we have 7x plus 7 plus 10x minus, and working out the distribution here as well, 5x, negative 5 minus 1 plus 5. Let me clean this. We know we already used the least common denominator. And combining like terms. Now we're going to combine like terms. We have this 7x with 10x, 17x minus 5x, 12x. Okay. 12x. And combine the numbers, the like terms that are just the numbers. 7 plus 5 is going to be plus 12. Very interesting. Now we have 12x plus 12 over x plus 1 times x minus 1. Can we make any further simplifications? Yes, I think so, because we can factor out 12, right? Factor out 12. And x plus 1 over x plus 1 over x minus 1. And look at that, you can simplify. You can simplify here x plus 1 as x plus 1. And this is going to be our solution. It's the simplest rational expression that is equivalent to this addition and subtraction of three different rational expressions with three unlike denominators.